Hey guys, so today we are working on some mass versus weight calculation problems. So it's only 10 questions, it's not a ton, and this is another example of a self-grading assignment. So when you type in the correct answer, this box will turn green. Of course, I'm going to do a few examples here for you, but I just wanted to point out something. So the formulas are over here. We're only using one formula. Weight is equal to force of gravity, aka newtons, right? Which is equal to mass times acceleration. So your acceleration of gravity on Earth is 9.8, and then it also tells you the force of gravity on the moon and on Jupiter, because some of these questions are going to ask you about weights on the moon and on Jupiter. So remember, F equals ma, force, aka weight, is equal to your mass times your acceleration due to gravity. So it's a 3 variable problem in every single one, and we're just going to type them in and solve for each problem. So the first 2 problems, please do not let those trip you up. They are asking you, so number 1 says a small dog is 10 kilograms on the surface of the earth. What is the dog's mass in kilograms on Earth? Remember, mass doesn't change, weight does. So if you see a question that's asking you about mass, mass is the same wherever you go. So if a dog is 10 kilograms on the surface of the earth, the mass is just always going to be 10 kilograms. And this particular sheet does not have you type in units, so you can just type in the number, okay? And question 2 is very similar to that one, okay? So let's do an actual calculation. Let's do number 4. So 4 says a small dog is 10 kilograms on the surface of the earth. That's its mass. Okay, the kilograms is in mass. What is the dog's weight in newtons on the moon? So we're looking for the force, because remember, weight is also the force. So the force is going to be equal to mass times acceleration. So the mass is 10 kilograms. And the acceleration on the moon, we see it in our formula over here, is 1.6 meters per second squared. So to find our weight, aka our force in newtons, we're going to have to do 10 times 1.6. So of course we'll need a calculator for this. So 10 times 1.6 gives us 16 newtons. Okay, so that would be the weight of the dog on the moon. Okay, so 16. Okay, and it turns green, so that is correct. So let's just do one more where we solve for a variable that's not newtons, just so we're all on the same page. Let's see. Okay, so number 9 says, what is the mass of a cat in kilograms who is 6 newtons on the surface of the moon? Answer to 2 decimal places. Okay, so this is an instance, again, we're still using the same formula, F equals m times a, but here we're given the force and we're given the acceleration, so we have to solve for kilograms. So let me just annotate really quickly. So we know, and again I'm doing number 9, 6 newtons will be equal to our mass, which it tells us that's what we're solving for. So we're solving for mass times our acceleration, and we're on the moon, so we're going to have to do the acceleration of gravity on the moon, which is 1.6 meters per second squared. Now to solve this, we're solving for mass, so this is just now an algebraic problem, so we're going to divide both sides by 1.6. So 6 divided by 1.6 is going to give us our mass in kilograms. And remember, we want to report it to both, or to 2 decimal places. Okay, so we're going to divide each side by 1.6, and that's going to give us the answer to number 9. So I'm going to exit my drawing and pull up my calculator. So 6 divided by, oops, let me just clear all this. 6 divided by 1.6 is equal to 3.75. And that is correct. So it's green. So those are 3 problems done for you, which means you only have to do 7. It's not a ton, and you know it's right because it'll pop up green. The only formula you have to use is F equal to ma. The force is in newtons. Okay, it's also your weight. Your mass is going to be in kilograms. And then your acceleration, which is the A part of the m times A, is going to be one of these 3 over here. So pay attention to the problem. Is it telling you that it's on Earth, on the moon, or on Jupiter? And that will tell you what your acceleration is. Okay? So if you don't have any questions, you guys can go ahead and work these 7 additional problems. Of course, if you're having troubles getting them right, please send me a message and I will be happy to help you.